Welcome to the Explainer. So, if you've ever hopped on a train here in the US, buckle up, because we are about to take a fascinating journey deep into the hidden technology that actually powers America's national railroad. Today, we're going to explore a massive architectural trap, we'll pull some brilliant insights from the most advanced railways across the globe, and finally, we'll break down a multi-million-dollar strategic crossroads that will literally determine the future of how we travel. It's a pretty perfect case study in the extreme, high-stakes challenges of modernizing legacy tech. Let's get into it.
To start things off, I want to expose what is essentially a brilliant illusion. When you book a trip on Amtrak today, everything feels, perfectly aligned with the 21st century. You've got this gorgeous digital experience, you're downloading digital tickets, you're tracking your train's progress on a sleek mobile app, getting instant push notifications. The customer-facing side projects this image of a seamless, modern, cloud-native railroad. But here is the crazy part. Underneath that polished app interface, none of this operates on the cloud. The entire booking and data ecosystem depends on a piece of architecture that literally predates the public internet. Amtrak's backend actually runs on a legacy system launched way back in 1981. It's a massive physical system built directly onto IBM mainframe hardware. So while the marketing team is giving you a modern experience, every single swipe, tap, and digital ticket you use ultimately routes all the way back to a 40-year-old computing monolith.
All right, Section 1, the facade and the trap. Let's look inside Amtrak's modern computing illusion.
Okay, let's dive into this. How did a national transportation network end up with this incredibly eccentric IT stack? And more importantly, why haven't they just, replaced it? Well, Amtrak's core systems are split into two main operational halves. On one side, you have Aero. Aero is insulated from the physical tracks. It handles the passenger data streams, credit card verification, passenger manifests, and all the financial accounting. Then, on the other side, we have CETC, the Consolidated Electrification and Train Control System. Because moving data is one thing, but moving actual trains through hyper-congested routes like the Northeast Corridor, that requires entirely different infrastructure. CETC manages the physical track switches, dispatch consoles, and high-voltage power lines across hundreds of miles. Now, over the decades, rather than rebuilding that central data core from scratch, engineers just built modern tools, stuff like SAP and Oracle, and wrapped them as external layers directly around Aero. Because of this layered structure, all those shiny new analytics dashboards and mobile apps still have to reach deep into the center and pull their raw data outward from that original 1980s mainframe.
Now, you might be wondering, why on earth is a system from 1981 still running the show today? Well, staying on this mainframe isn't just a result of corporate laziness, it actually exists out of pure functional necessity. See, Aero relies on IBM's Transaction Processing Facility, or TPF. TPF was engineered by IBM for pure, unadulterated speed. It can process massive blocks of transactions in absolute fractions of a second, which, by the way, is exactly why major global banks and heavy-duty airline networks still rely on it right now. Amtrak operates a nationwide network that requires absolute precision. If a ticketing or dispatch query drops, your train literally stops moving. So near-zero downtime isn't just a nice-to-have luxury, it's a hard, non-negotiable operational requirement. And until a modern cloud platform actually proves it can handle millions of concurrent, real-world human transactions with that exact same airline-level reliability, this old green screen technology simply cannot be turned off.
And trust me, they have definitely tried to turn it off. Executives are always pushing to decommission the aging hardware to save money, but piling decades of modern software onto an old foundation creates a massive structural trap. The new systems are so entirely dependent on the old data streams that the legacy core becomes virtually impossible to extract. In fact, Amtrak actually attempted to escape this trap back in 2009 with a massive, fully funded project called Res-NJ. It was explicitly designed to shut Aero down for good. They spent millions of dollars, but the whole thing collapsed completely. The technical challenges were just so severe that nearly half of the planned software modules were never even finished. Aero is tethered to thousands of points across the whole system. Trying to pull that central node out is literally like trying to swap out the engine on a passenger train while it is barreling down the tracks. If you remove the core, the entire network just goes dark.
Moving on to Section 2, Lessons from Global Railroads, looking beyond the US for a modern solution. So it's pretty clear that a standard lift-and-shift IT modernization simply is not going to work for a railroad of this scale. To find a way out of the trap, Titan Software conducted a major technology evaluation, looking at the very best global technologies out there. The goal wasn't just to somehow migrate 1981 tech to the cloud, but to identify what is actually working internationally and combine it. And the results are fascinating. China demonstrated the world's largest passenger reservation platform, processing just enormous transaction volumes using AI for dynamic scheduling and biometric ticketing. Japan, meanwhile, showcased exceptional reliability with near-zero latency, real-time operational control. And Germany demonstrated advanced multimodal integration, open APIs, and these incredible digital twins that support future expansion. All of this proves one thing: a much better, highly reliable, modern way absolutely already exists outside the US.
And one massive innovation inspired by those implementations in Asia could completely change how you travel. We're talking about AI-driven voice and vision biometrics. Just imagine a future where you don't even need a paper ticket, or frankly even a QR code on your phone. The process is incredibly simple. You purchase your ticket online, and your biometric identity literally becomes your ticket. When you arrive at the station, you just walk through the gates using face or voice verification. An AI confirms your identity in seconds, and you proceed directly to boarding. No fumbling around. This single innovation would dramatically reduce boarding delays, improve physical security, cut down on ticket fraud, and vastly enhance the convenience for the everyday traveler. Which brings us to Section 3, the cognitive rail vision, designing the ultimate best-of-breed architecture.
And this brilliantly illustrates what they're aiming for. Taking all of those global lessons, the vision is no longer to just patch up ARO and CTC. It's to position Amtrak as a global leader in intelligent rail transportation. This is the proposed Amtrak Cognitive Rail System, or ACRS, a brand new cloud-native design that throws out the 1980s mainframe entirely. Let's walk through the layers here. Right up at the top, you have Layer 0 biometric entry. This is where those Chinese-inspired face and voice gates sit, interfacing directly with passengers and third-party apps via a multimodal API. Beneath that is the cognitive backbone. This utilizes a hybrid cloud setup with Microsoft Azure and Oracle Cloud Infrastructure. This is where the heavy lifting happens, the digital twins of the rail network, AI pricing, and real-time scheduling. And critically, down at the bottom, we have Layer 3, edge safety and real-time control. This isolates the safety-critical moving block systems and IoT sensors, guaranteeing that zero-latency performance inspired by the Japanese rail network. It's truly a best-of-breed architecture.
But of course, building a visionary system like this brings us straight to the hard numbers. A brand new, state-of-the-art ACRS build is estimated to cost around $245 million over roughly 4.5 years. But here is the wild part. Trying to carefully untangle and incrementally migrate the legacy mainframe is estimated to cost pretty much exactly the same, between $220 and $280 million. And it could actually take longer, up to 5.5 years. So while the new build carries a higher upfront risk because you're starting from a completely greenfield state, the incremental migration means you are actively choosing to retain decades of technical debt. You're paying the exact same amount of money, but you're missing out on the cutting-edge AI and the biometrics.
But beyond that initial build cost, here's why pulling the trigger on modernization is fundamentally necessary. Once the project is finally complete and that massive IBM mainframe is officially decommissioned, estimates project a jaw-dropping 50 to 70% reduction in the annual total cost of ownership. We are talking about tens of millions of dollars saved every single year in legacy maintenance, software licensing, and those highly specialized staffing costs, all while opening up entirely new revenue streams through optimized AI pricing. It's a game changer.
Finally, Section 4, 3 Paths to the Future, the strategic crossroads for Amtrak's digital evolution.
So the technical roadmap is drawn, and it leaves us with an incredible executive dilemma. There are 3 distinct strategic options for Amtrak's digital evolution. Path 1 is incremental migration. This is your safest option. It reduces operational risk by replacing components gradually, but as we just saw, it basically preserves the limitations of the legacy architecture and keeps all that technical debt alive. Path 2 is the ACRS new build. This is the ambitious maximum innovation route. It definitely carries higher implementation risk, but it delivers the biometric ticketing, the digital twins, and the future scalability that could instantly make Amtrak a global leader. And then there's Path 3. The hybrid evolution strategy. Honestly, this is often the pragmatic reality for massive legacy organizations like large banks and airlines. You perform a limited migration of the critical systems first, just to drop the immediate risk, and then you gradually transition toward the new cognitive architecture over multiple phases right alongside it. It perfectly blends safety with vision.
So, we've laid out the technical trap, we've seen the brilliant global inspiration, and we've analyzed the multi-million-dollar business choices. The facade of the modern app is hiding a 1981 mainframe that desperately needs replacing, but taking it offline threatens the entire physical rail network. It's this incredibly delicate balance of risk-reward, safety, and innovation. I want to leave you with this final provocative thought. If you were the CEO of Amtrak, sitting in the executive boardroom with these blueprints laid out on the table right now, which of the three paths would you choose to modernize America's railways? Thanks so much for joining me on this explainer, and I really hope this deep dive has given you a completely new perspective on the invisible technology that keeps our country moving.